Hi, welcome to our video series on operating systems. In this video, we cover the interrupt handler process and important and applications of interrupts. Here, interrupt handler. An interrupt is a signal that the processor receives from the hardware or software to be processed. This interrupt handler is the procedure that starts when an interrupt is generated. By granting access to the interrupt handler, the CPU interrupts the running process and stores its state before focusing on the interrupt. We refer to the complete procedure, the interrupt handler. Here you can observe the picture of the interrupt handler, and here one more picture of the interrupt handler. You can see the website link also. And here roll up an interrupt handler. First thing is save the processor state. The interrupt handler usually saves the processor current state, which includes the program counter or register and other pertinent data before processing the interrupt. When the interrupt has been handled, this enables the handle to pick up where the previous program left off, reacted to the interrupt. The interrupt handler looks into what causes the interruptions and takes the appropriate steps to address the occurrence. This could be getting information from the device, updating a data structure, or starting a certain process. Here, restore the processor data. Here, we can interrupt has been handled, and interrupt handle goes back to the processor saved state and picks up where the interrupt application left off. And few more roles we can see here. The type of interrupt and its requirements are determined by the interrupt handler. The purpose of the interrupt handler is to be recorded and interruptions and identify their source. Occasionally the interrupt handler carries out extra work in an attempt to stop interruptions in the future. The handler then respond to interruption by carrying out a certain set of commands. The interrupt priority is also set by the interrupt handler. Low level interrupt masking is also responsible to the interrupt handlers. Here, interrupt handling process, we can see the stages involved in managing interrupts are follow. Here, one of the step is request for interrupt. One of the first step is request for interrupt. In this process, CPU receives an interrupt request from the programmer or device. Second step is interrupt service routine, means ISR. In this process, the CPU saves its current state and jumps to the appropriate interrupt service procedure. Code that manages interrupt and carries out the required operations is called as interrupt handler, means ISR. And next one is interrupt masking. To stop other interruptions from interfering with the current ISR, the CPU may mask or disable certain interrupts while ISR running. Next thing is like interrupt acknowledgement. The processor notifies the device or program that the interrupt has been handled by sending an acknowledgement signal when the interrupt handler routine is finished. Next one is interrupt unmasking. Any previously maskable interrupts are subsequently unmasked by the CPU or enabled. Written from ISR. The processor resumes exception of the program at the location it was in. Here you can see the interrupt handling process picture, and this is also more details interrupt source and processing handling pictures. Here you can see the importance of interrupts in modern computing by doing away some of the points here. By doing away the ongoing polling interrupts, maximizing the CPU utilization. This improves system performance by enabling the CPU to execute tasks more efficiently and react to event faster. In embedded system, medical devices and automotive controls interrupts follow for an instant real-time response to crucial event. guaranteeing a prompt and accurate system reactions. Next thing is by enabling multitasking and managing asynchronous events. Interrupt plays a critical role in maximizing the performance of operating system and applications by facilitating effective task switching. By quickly indicating the need to address peripheral or internal problems, interrupt improves a system responsiveness and stability, aid in effective resource management. By bringing portable and battery powered devices processes out of low power modes and enhancing the power management. Here you can see the interrupt applications. Here I am discussing about two interrupt applications. One is hardware and one is software. In hardware, in data entry with simple interruptions, application for counting and time-based uses. In software interruptions, application to evaluate different internet service providers to add program break points of debugging. And next last thing is to initiate bio process on computer of IBM SPC type. Here you can see the real examples, two real examples of where you can using real world applications and scenarios. One is system embedded. Scenario monitoring is in industrial automations, Internet of Things devices, and environment monitoring systems. Inter- Interrupts are used to manage real time sensors, data from the sensor like temperature sensor, accelerometers, and gyroscopes. Control systems. Engine control units, ABC barking systems, and airbag developments are just a few of the vital functions that interrupts in automotive applications handle to ensure quick reactions of change. Here, next thing is operating systems. Interrupts in operating system process scheduling. In contemporary operating system, interrupts are essential for primitive multitasking, enabling the CPU to move between processes according to priority and guaranteeing adequate system calls. Software interrupts, sometimes known as traps, allow user level programs to communicate with the kernel of the operating system and obtain resources such as memory management, file output, and input.